All right, so our next quantum number is L. L is the angular momentum quantum number, and it's usually written as a lowercase cursive L. So L determines the shape of the orbital. And L is allowed to equal 0, 1, 2, so on and so forth, all the way to n minus 1. So it can never be larger than n or equal to n. So for example, if n is equal to 1, L is only allowed to be equal to 0. If n is equal to 2, L can now be 0 and 1, right? It can go up to n minus 1. 2 minus 1 is 1. If n equals 3, then L can equal 0, 1, or 2. So generally, we don't refer to L as the number value. It gets a letter instead. So if L is equal to 0, right, that's the number, it gets the letter S. If L is equal to 1, what you'll see is actually gets the letter P. So we call it an S or a P orbital. We don't say L is equal to 1 or L equals to 2. When L is equal to 2, we call that a D orbital. When L is equal to 3, we call that an F orbital. And we won't go beyond that. It also determines the shape of the orbital. So an S orbital, it looks like a sphere. So pretty simple there. A P orbital looks like a dumbbell, and there's 3 of them in basically 3 different orientations. A D orbital looks like a 4-leaf clover. And then there's 4 of those. And then there's another weird one with like a dumbbell with like kind of like a ring around it. So we'll just say 4-leaf clover. And a weird one. And then the F orbitals kind of look like 2 4-leaf clovers or 2 D orbitals. And we won't even attempt to draw that one. If you're wondering why they're getting these funky shapes, it's all related to quantum mechanics, the wave nature of the electron, and basically the electron wants to get as close to the proton as it can because the proton is attracting it because the proton in the nucleus has positive charge. But we won't get into complex quantum mechanics overall. Here's just a nicer pictures of this. All right, so there's the S orbitals, right? You can tell it's a sphere. Here's the P orbitals. They look like dumbbells. You can tell that they're in 3 different orientations. Here are the D orbitals. You can see that they look like 4-leaf clovers with this kind of weird one in the middle. And then this whole bottom row is the F orbitals. There's 7 of them. You can see they kind of look like 2 D orbitals mushed together. Just be able to draw the basic diagram of an S, P, and D orbital. If we're wondering how this part relates to the periodic table, right? So there's our sketch of the periodic table. These first 2 columns are what's known as the S block. And that actually includes helium as well. And then this block over here, these 6 elements over here demonstrate the P block. In the middle right here, we have the D block. And then down here, we've got the F block. So your N corresponds to which row you're in. The S block tells you the approximate column that you're in. Or the L value tells you the approximate column you're in.